let's talk about loops. Now, again, for us, part 2 of this dictionary definition of the word loop is more related to the type of things that we are interested in. And why loops are fantastic is because it's about working smarter and not harder. A loop will handle repetitive code for us and adjust dynamically if we need it to. Loops are awesome. So like putting a nail into a piece of wood, you're going to hammer that nail until it becomes flush with the wood, right? You're not going to stop short. You're not going to drive that nail past it. You're going to want to hammer that nail till it's flush with the wood. So keep hammering. Is it flush? Is it flush? Is it flush? No, it's not flush. Now it is. I'm going to stop hammering. A loop does the same kind of thing. So these are your basic loops in JavaScript. There are other types of loops, but they're mostly variations on these. And while each of these pretty much do the same thing and have the same parts configured in different ways, you might choose to do one over another because of the way it's constructed, or just different circumstances require different loops. It is important to note that the do loop is the only loop that will run always at least once before it stops. So, as I mentioned, loops are an efficient way to handle code that needs to repeat. The DRY principle stands for do not repeat yourself. Really important in programming, especially when we want to work smarter and not harder. There's no need to keep writing code over and over and over and over again when you can write code more efficiently. If you can write one line that does, or 2 lines even, that does something that if you just repeated it over and over and over again, you could like say I need something that works 5 times, and it works 5 times, and I just write code that repeats 5 times. Well, I can write it once and have a loop repeat it 5 times. These can be used in conjunction with arrays to get values out, and we'll talk about that. I mentioned before, document object elements are organized in array notation. That square bracket next to children is indicative of an indice of an array. So document.body.children, a square bracket 0, would get the first element within the body of whatever HTML page you are on. Okay. So all loops have a loop type defined by a keyword. So for, while, do. An initializer. So like we use the letter I to stand for that. A test condition that basically says, as long as this condition is true, keep running this loop. A counter of some kind, and a code block to execute within the loop. So for that loop. And the primary difference between these loops are how those elements are organized and what changes and how they are run. We'll see an example of my favorite kind of loop, the for loop. It starts counting from the value of the initializer by increasing the initializer's value according to the value of the counter. So this var I equals 0, I for initializer equals 0. Then it's going to say, hey, how many times do I need to run this? As long as I is less than 10, that's going to be true. Then I plus plus, add 1 to I. So the first time it goes through the loop, I is going to be 0, right? Then we add 1, it becomes 1. Is 0 less, I should say, the first time it runs the loop, I is 0. We look at the test. Is I less than 10? So yes, 0 is less than 10. Cool, I'm going to increment that value of I to 1 now, and I'm going to alert hello. Okay, and I'm going to increment the word hello. I'm going to go through the loop again. I'm going to check on the value of I. Is I, which is now 1, less than 10? 1 is less than 10. Cool. I'm going to now set the value of I to 2. I'm going to check. Now I'm going to do alert again. I'm going to alert this, so I've done it twice, and then I'm going to keep doing it until I is no longer less than 10. So I starts at 0, it goes to 1, it goes to 2, it goes to 3, it goes to 4, it goes to 5, it goes to 6, it goes to 7, it goes to 8, it goes to 9. That's a 10. 0 through 9 is 10 items, if you think about it. So it would alert hello 10 times. The while loop basically has the same thing. It's got a keyword while. The initializer needs to be set outside of the while loop because a loop basically starts at the top, reads itself through the whole code brace, and then exits at the bottom. If you had the variable I inside of the while loop, it would constantly reinitialize itself as 0, and then you'd get an infinite loop. Bad. That initializer needs to be outside of the while loop. So you have a while, and then you have the condition. As long as that condition is true, that test, as long as that test is true, it's going to keep executing the code within the curly brace. So just like the for loop, this is going to alert the value of I 10 times. So instead of hello, it's going to say 0 through 9. And then it's going to stop because I will no longer be less than 10. I will then be 10. And it then stops. The do while loop. And this example is from the previous JavaScript book that we used to have in the class. I really enjoy this cute little bit of code. So here it says do. I'm going to check a variable called lucky number, which uses what's called a prompt. So just like an alert pops up a message, a prompt asks a question. And the question that gets asked is, what is your lucky number? And you as the user would type in a number, and that would be automatically stored in the variable lucky number. We would make sure that it's a number and not a string. That's why we're using parse int. And then we're going to test while isNan. So isNan is basically, we're going to check to see if lucky number, if somebody typed in the word 7 versus a number 7. If they type in the word 7, it's not going to parse int properly. So it's going to come back as not a number. So it says, hey, as long as lucky number is not a number, I want you to run this loop again. That's a fun little bit of code, but always the do loop happens at least once. An infinite loop, you want to avoid the infinite loop because it can crash your browser. It's a logic error. There's lots of problems with it. So think for a minute why this might be an infinite loop. I initialize the value of I as 0, and I check to see if I is less than 10. And if I is less than 10, I'm going to decrease or decrement the value of I. So the first time I go through the loop, I's value is 0. It's less than 10. It's true. I'm going to alert I. The second time I go through the loop, 0 minus 1 is -1. I is less than 10. I never, ever becomes false. I never becomes anything other than less than 10. That condition is always true. It will always run the loop, and it will constantly run that loop, and that will create an infinite loop. Part 3, flow. Again, both of these apply to flowcharts. Flowcharts help us see the steady stream and define where the forks in the river should go. XKCD is a geeky webcomic. And here is one example of the webcomic. So here we can see start project. Do we want to do things right or do them fast? So let's start with fast. So we're going to code fast. And then we check, does it work yet? No. Okay, we're going to go back to code fast. And we're going to keep going through that until finally it works. but we never get there. So almost, but it's become a mass of kludges and spaghetti code. That's just a bunch of like code that gobbledygook and you can't really understand it and it's not clean. Let's go back to the beginning. Throw it all out and start all over. Start the project. Do things right or do them fast. Well, fast didn't work out for us last time. Let's do things right. Okay, then we're coding well. Are you done yet? No, coding well sometimes takes time. Are you done yet? Are you done yet? Are you done yet? Well, finally you get to no and the requirements have changed. Throw it all out and start over. Well, it's only funny because it's true. It does happen. So, what are flowcharts actually good for? It helps us with building this step-by-step picture for the process. It helps us kind of break things down into smaller pieces so that we can figure out what to make our code do in what order. It helps us find areas of improvement in a process, like maybe you see that you're having to do the same step multiple times. Well, maybe a loop would be a good thing to do. It helps us find ways to improve the process and helps us define the process and analyze the process. How is it that we want things to work? It's basically like a blueprint for you to write your code. So this is kind of like measuring twice and cutting once. You want to have some kind of a plan in order for you to execute your code. You will hear me and several of the other web teachers at Platt say you need to have a plan. Plans help. When you did responsive, you had a plan. And those plans helped you execute your code better and keep your goal in focus. That's what a flowchart will help you do with your programming. These are the flowchart shapes that I'm going to want you to use. The terminus, which is this start or end, it's called the terminus. A decision point, seen as a diamond. A process or task, and then the sequence. Make sure that you have this arrow. Please use these shapes and the arrow for the direction in which the flowchart is flowing. I'll show you an example of that in a moment, but I don't need anything fancy here. This is what I want. This is what I'm asking for. Don't give me stars. Don't give me moons. Don't give me hearts. Terminus, diamond, rectangle, square, arrows. So here's a super simple example. I'm going to the store and I have a list of items. In fact, I went to Costco today and I went, okay, I need eggs, I need butter, I need Kerrygold also, I need sandwich thins, etc., etc. So I'm going to go to Costco, for example, and I've got my list of items. And I'm going to go get eggs. Are there still items left on my list? Yes. I'm going to go get the sandwich thins. Are there still items left on my list? Yes. I'm going to go get the butter. Are there still items left on my list? Yes, etc., etc., etc. Until I have no more items on the list, I'm going to go up to the front and check out. So obviously this could be more complicated, but it gives you a basic idea. Okay, I'm going to do this set of commands, and when they're done, I'm going to do the last thing. That's the end of my script. So, in this case, right, it was getting a set of items from the store. That's my goal. I need to get all the items on this list. That's my goal. I need to get all the items on this list. Then I want to design the script. Get an item. Check it off your list. See if you have more stuff on your list. If you have more stuff on your list, go get the next item. And so on and so forth. A flowchart can help you split larger goals into smaller steps and kind of figure out how to get from point A to point B. And then once you've made your plan, it will be easier to write the code. Trust me on this. I've done this a lot, and just having kind of that process in mind is very beneficial. Here's a joke. Programming joke. A wife asks her husband, who is a programmer, could you please go to the store for me and buy 1 carton of milk? And if they have eggs, get 6. The husband nods, goes to the store. A short time later, he comes back with 6 cartons of milk. The wife asks him, why did you buy 6 cartons of milk? He replies, they had eggs. Computers do exactly what you tell them. If you have a problem with a result where the program is working, there's no errors, but the result is not what you think you asked for, it's likely that you have what's called a logic error, and these are the hardest to solve and work through. Again, flowcharts help sort these out. So let's take a look at this joke in code. Here we have eggs. Their current value is 1. So they're greater than 0, right? Our current value for milk is 1 carton of milk. The husband has a go to store function. We're adding the milk argument in, so it's 1 carton of milk. We're going to check if eggs are greater than 0. Yes, they are. We're now going to reset the value of milk to equal 6 cartons of milk. We're going to use the return keyword and say return the new value of milk. That's going to be 6 cartons of milk. In a flowchart, you can see this much easier. Are there eggs? Yes. Milk equals 6. Buy milk. We're going to bring 6 cartons of milk home. We're not going to get eggs. She didn't say get eggs. She just said, if there were eggs, get 6. She didn't say 6 what? She just said 6. And the implication is that it's milk. We as humans understand that she really meant get 6 eggs. But computers aren't human. They don't understand things the way that we do. They don't make inferences. So you can see where the error is in this situation, and that's why a flowchart is good to have and to use. And even when you're troubleshooting something, a flowchart can be very beneficial. That is the end of this lecture. I hope that this brings you understanding and enlightenment when it comes to programming, and I will see you in class. Thanks.